Hi, my name is Jeff.
Hi, I'm Josh, and for our EE3 project, we decided to make an Android accelerometer-controlled RC car that would go forwards, turn, or go backwards, based on which direction the phone was tilted. The car also had to do this wirelessly through Bluetooth. So to do this, we had to first start with an RC car and completely change the internals, as you'll see in the next few slides.
Okay, so for the Bluetooth, the process that we used involved an Arduino Uno, which unfortunately does not come with Bluetooth access. So to remedy this, we had to use an HC06 Bluetooth module to allow the Arduino to connect and receive information and controls from an Android phone. And while the car could connect to any Android phone, for this project, we used solely a 1+1 device. Okay, so for the RC car itself, we obtained a 1/24 scale Lamborghini RC car to modify, and unfortunately the top of the car had to be desecrated and removed in order to make such modifications. And one modification was that we had to remove the original circuitry and remove any wires that were unnecessary to replace with our own. And then we also had to modify the battery pack because the total voltage was around 4.5 volts, which wasn't enough because the minimum was 6 volts. So therefore, we had to add another AA battery to the car itself, and this was placed right between the circuitry and the back motor. And then, in order for the power from the battery to be accessed, we had to first file down both tips of that battery, and then also we had to solder wires to each side as well. We also had to drill holes into the exteriors of the car so that the wires from the batteries can be reached, and also from the Arduino to be reached to the bottom of the car itself. And then this is our schematic for the RC car, and some general things about it is that the batteries, they were connected in series, and then they were connected to the ground of the Arduino. And functionalities such as the light and speakers we decided to omit because they were deemed non-essential to the project. And then the two motors were connected to the L293D H-bridge motor on either side, H-bridge motor driver on either side. And then the HC06 Bluetooth module was attached to the breadboard and linked to the Arduino via wiring. And then the state port on the HC06 was used to check the connection of the Bluetooth. So if the car was out of range, then the car would stop moving. And this was done by soldering an additional wire onto the module itself.
As for our code, the motor movements were simple and similar to any other motor driving unit. The tricky part came when translating Android tilt movements to motor movements. Luckily, there is a pre-built app on the Android market that sent characters, such as usually just letters, that would correspond to a certain degree of tilt. And for example, a leftwards tilt on the Android phone would emit a letter L that would transmit that through Bluetooth over to the HC06. From there, all we did was, if the HC06 received a letter L, the car would turn left, and so on and so forth for the other letters. So we just repeated this for 8 directions of tilt. Other problems that we encountered during this was, since the new internals of the RC car included an Arduino Uno, a motor driver, and the HC06, the usual 3 AA batteries that were used to power the car did not have enough voltage to have the wheels spin and turn at the speed we wanted to, and thus, with all the additional weight from the parts we used, there was not enough torque to make the car accelerate very quickly or go really that fast at all. So what we tried was adding more AA batteries, but with that there was an extra weight that was involved. So the car, even though we had more voltage going through, the car would just be essentially the same speed because there's a lot more weight from each battery. We also tried using 3.7 volt batteries. LiPo is used for small things like micro mouses or something, which gave us a total of 11.1 volts. But since they were connected in series, the ampage was still around 500 milliamps, which is not enough to power to handle the load of the motor compared to 1.5 amps from each AA battery. We also tried using two 9 volts connected in parallel to get more amps, but it also had the same problem as the 3.7. So essentially, if we had a lightweight 12-volt RC battery that had a decent ampage above 1 amp, all the problems would have been solved, but we just didn't have access in time. Yeah. And for our end result, in the end, our car had the speed, did not have the speed we originally wanted due to the battery weight problem. But the main focus of our project, which was getting the car to move forwards, backwards, left, and right, wirelessly through Bluetooth based on the degree of tilt of the Android accelerometer, worked the way we wanted it to.
Thank you.